Today, in this lecture, we are going to discuss the different generating circuit of the amplitude modulation. So, we already know the definition of amplitude modulation is that changing the amplitude of the carrier signal based on the message signal. So, uh, the second type of circuit is known as switching modulator. Switching modulator, as the name switching modulator. So the basic switching device is the diode. So we can use diode as a switching component for the switching modulator. So again, the circuit diagram of the switching modulator is here. Adder. So to the adder we give MT message signal, and then CT carrier signal, and then the output of the modulator will be given to our diode. The output of a modulator is given to a diode, and then after that you can use a band pass filter, and then after that you can use a so RL band pass filter. So this one is the diode. So this is the input of the diode, and that is the output of the diodes. So we the basic function, the functioning of diode, we know that if for positive cycle, diode will be forward biased, and for negative it will work as the reverse bias. So we know the basic functioning of the diode is that if you have more voltage, like the positive voltage, the diode will be looking as a closed switch, and if you have a negative voltage, then the diode will be working as a open switch. So what is the input? Like VIT. So VIT is basically the addition of CT and MT. MT plus CT, so which is equals to MT plus AC cos omega CT. The second thing that condition you must satisfy, that's the amplitude of CT should be much bigger than the amplitude of MT. Like the amplitude of CT should be much bigger than the amplitude of MT, so that the diode will be working as a forward bias device. So like you can say something like that: the output of the diode will be equals to VIT if your CT is much bigger than 0, or you can say positive, and then otherwise VOT will be equals to 0 if the amplitude of CT is less than 0 or negative, because we know that in that case the diode will work as a open switch device. So we know that the pulse of the carrier, like we know that the carrier is something like this, and the functioning of the diode will be based like, because it has some, when it is positive value the diode is forward, when it is negative values the diode is a reverse bias. So it means that you have pulses something like this. So minus t by 4 to t by 4, and another pulse is like minus t, and that is t. So this is the pulses of that the diode will give you, that is the output of the diode. Like it looks like a half duty cycle. Half duty cycle, because sometimes the half of the cycle the diode will work, the half of the cycle the diode will work, and half of the cycle the diode will be off. So that is why it is 50% on and off. So because it is 50% on, so that is why the duty it is you can say that is half of the duty cycle. So the output will be equals to, so you can say that the output basically will be equals to VIT multiplied by the pulse. And what is pulse? So pulse, the definition of the pulse is the power series, so which is equals to 1 over 2 plus pi by 2 summation n is equals to 1 to infinity minus 1 power n minus 1 divided by 2 n minus 1, and then cos omega ct, and then 2n minus 1. So that is the cos, that is the pt, and we know what is VIT. So VIT basically the sum of the message signal and the carrier, cos omega ct. So this is equation 2, and then this is equation 1. So you can say multiply both equations 1 and 2 to get VO, or to get the output voltage at the load resistor at RL. So that is VOT is equals to MT plus AC cos omega CT, and then you are going to multiply it by 1 by 2 plus pi by 2, n is equals to 1 to infinity minus 1 n minus 1 divided by 2n minus 1 cos omega ct, and then 2n minus 1, and then this is the resultant. So this is the maximum possible values. But if you choose a few values of n, let's suppose you have n is equals to 1, so you can choose different values of n. But suppose you choose n is equals to 1, so if you choose n is equals to 1, so this equation will be equals to mt plus AC cos omega ct, and then 1 over 2 plus pi by 2 into 1 over 1 by 1 cos omega ct, and then plus, so if you choose n is equals to 1, so then plus minus 1 to the power minus 1 to the power 1 divided by 3, and then this one is equals to cos n is so 2 mega cos mega ct, cos mega ct, so cos 3 mega ct, plus 2 to 2 is the 4, so 4 minus 1 equals to 3, so that is 3. So if you keep multiplying these values, so the answer is m by 2 plus pi by 2 mt cos mega ct plus minus 1 by 3 mt cos 3 mega ct plus ac by 2 cos mega ct plus pi by 2 cos square mega ct and then plus minus 1 by 3 cos mega ct and then cos mega c 3 mega ct. And then after passing through band pass filter, so this is a low frequency, so it means that the band pass filter will not allow to pass that circle. It will not allow to pass this one will pass, it will not allow to pass this one, it will not allow to pass so this one. So after the band pass filter, your output will be equals to pi by 2 mt cos omega ct and then plus this one is ac by 2 cos omega ct, and you can take out the common ac cos omega c by 2 ac by 2 cos omega ct 1 minus 4 pi by 2 4 pi by 2 AC and then empty. So this is the output, and we know that phi of like amplitude modulator circuit AC cos omega ct 1 plus modulation index empty. So it means that in this case it looks like that the modulation index is equals to 4 pi by 2 AC, 4 pi by 2 AC. So if we replace that part here, so you will end up with the equation. So AC by 2 cos omega ct 1 plus mu of mt. So you see, so that is the output of the switching circuits. So you can see the output of the switching circuit is again the phase modulated output. It is the equivalent to the phase modulated output. So that's all for today's lecture, that we have discussed the switching modulator, and the output of the switching modulator is also the phase modulated signal. So I think that's all the generation of amplitude modulation we have done up till now. And if you have any question, you are most welcome. You can ask question in the comment box and we will hopefully reply with our best answers. So thank you for watching the video.